Hey scholars, so let's get some more help with compound probability using tables and organized lists. So one of the easiest ones we can do is flipping 2 coins and making a sample space table, and then we can look at how that looks like in an organized list. So here I have my coin 1 and my coin 2. These kind of work like Punnett squares, and when you do biology, they kind of work like multiplication tables. What we're trying to do is we're trying to see where they match up. So I'm actually going to kind of draw some lines here. So I have boxes in here. So I could do on the first coin heads and the second coin heads. And so I would write that as HH. So I can see this is heads, this is heads. Or the first coin could be heads and the second coin could be tails. Heads and tails meet here. Or the first coin could be tails and the second coin heads. Or we could have both be tails. Now, if we wanted to write this as an organized list, we could say, okay, both are heads. We could say change the second one to tails, swap them, and then both tails. So we can still see those are all of our options. Now, these are really good to use, especially when we're talking about rolling 2 dice. So if I'm rolling 2 dice, we know that I could get 1, 2, 3, 4, 5, or 6. So let me make my little table here. And I'm gonna just kind of draw some lines. It might not be quite straight, but that's okay. So when we're playing like dice games, a lot of the times we want the sum of the dice. If like Monopoly, you're rolling 2 dice, you want to see how far you go. You're playing anything almost, and we want to see like the sum of the dice. There's lots of games where like you need to get the number 7. So instead of just writing 1 and 1 or 1 plus 1, I'm going to actually just add them up in my sample space. So if I rolled a 1 and a 1, I would get 2. If I rolled a 1 and a 2, I'd get 3. And a 3, we get 4, and we can just kind of keep filling this out. Or I could roll a 2 and a 1 here, get a 3, a 2 and a 2, get 4, 2 and 3, get 5, and just keep kind of going with that. 2 and 4 is 6, 7, 8, 3 and 1 is 4, 3 and 2 is 5, 6, 7, 8, and 3 and 6 is 9, and you'll start to see some patterns here. We're just kind of filling it in all the way across so we can see all of the possible sample spaces when we are rolling 2 dice. Now, if I was rolling 3 dice, this wouldn't be a strategy that would work because we would have to make a table in like 3 dimensions, and we can't really draw that easy for us to see. Okay. So if I roll 2 6s, I get 12s. So now if I'm playing a game and I want to roll a 7, I could look for how many times there's a 7 on the table. Well, there are 6 7s out of 36 possibilities. So it'd be 6 out of 36, or 1/6 of the time. Or if I wanted numbers that were, let's say, smaller than 4, right? I can only do that 3 out of the 36. 3 out of 36. That is going to be 1/12. So using a table like this for like sums, or like showing I flip a coin and I roll a die, is kind of easy to see your whole sample space in one go. It's easy to highlight and mark up things so you can see how many times certain things happen. So tables are a really nice way to organize our sample space when doing compound probability.